Hello students, you are welcome to Physics for Everybody. So we continue our preparation for your IGCSE exam. Today we'll be working on paper 4, variant 1 of the May June 2023. Okay, yeah, and of course you put down your name and fill all of this. This is the first video. I'll be producing 11 videos on this playlist, and each of these videos will be short, just 10 minutes duration. This is the link to this playlist. Okay, so I will add up to total of 10 videos, total of 11 videos will be on this playlist. Please make sure you save this link, okay, so that you can always come back. A video will be uploaded every day. Let's go straight to question 1. Figure 1.1 shows a straight section of a river where the water is flowing from right to left at a speed of 0.54 meters per second. Okay, so the water is flowing from right to left. This is it. This is the direction of the water current. Okay. Now, a swimmer starts at point P and swims at a constant speed of 0.72 meters per second relative to the water at right angles to the current. So these swimmers swim relative to this water at a speed of 0.72 meters per second. This way. This one swim this way at right angle to the current. Do not forget that the current is this in this direction. So they are at right angle because the angle here is 90 degrees. I'm sure this will remind you of something, Pythagoras theorem. Let's continue. Determine relative to the river bank both magnitude and direction of the swimmer's velocity. So a problem like this will be solved using Pythagoras theorem. I remember Pythagoras theorem. We'll use this formula: square root of a square plus b square. That's the formula we use for Pythagoras theorem. Yeah, so that's the question. This is based on vectors, okay? Like imagine there is a man and there are two forces at right angle acting on this man, okay? Imagine this man standing upright and then you tie a rope, apply force of 4 Newton forward, you tie another rope, apply force of 3 Newton in this direction. If you want to get the resultant, the resultant will just be as if there is a force of what magnitude? We get the magnitude, but at the end the magnitude we get to be 5 Newton. It's because if there's a force of 5 Newton acting in this direction. And to get that correctly, we imagine this force of 4 Newton to be this way. Just keep your eyes on this. This will be the force of 4 Newton. This will be the force of 4 Newton. Okay. And then this is the 4 Newton force. Then the 3 Newton force, we can just put it up here. That is here. Okay. I mean here. We can put the 3 Newton force here, 3 Newton. Then the resultant will just be this third force that acts along this part. And this is a right angle triangle. How do you get the diagonal of a right angle triangle? The diagonal of this right angle triangle represents the resultant. So let me just use color red to represent the resultant. This will be the resultant. So to get this resultant, we just use Pythagoras theorem. That will be square root of 3 squared plus 4 squared. Okay, that will be square root of 3 square is 9, 4 square is 16. 9 plus 16 is 25. So square root of 25, that will give you 5. That's how you get the resultant in this case. So that same phenomenon will be applied here, okay? The swimmer swims at a speed of 0.72 meters per second. So this is the speed of the swimmer. So this is the speed of the swimmer, 0.72. This is the speed of the current, 0.54. So we use Pythagoras theorem. So we take the square root of 0.54 squared plus 0.72 squared. Now we take the square root of 0.54 squared plus 0.72 squared. So let's use our calculator to do that. 0.54 squared. Okay, yeah. So 0.54 times 0.54 plus 0.72 times 0.72. This will give us 0.81. Yeah. So the resultant will be, this is what we're working on. Square root of 0.81. If you put this in your calculator, you get 0.9. You get 0.9 as your answer. Square root of 0.81 is 0.9. So that's the resultant. So that's the answer you put here Magnitude of the resultant 0.9. Now, what about the direction? How do you get the direction? Do not forget that the resultant is this single force here. I'm using this red ink to represent the resultant. This is the resultant force. How do you get the resultant? Okay, so look at what you have here. Determine the relative to the river bank. This is the river bank. So what's the angle theta? Angle between the resultant and the river bank. This is the angle we need. This angle theta here, this is the angle between the river bank and the resultant force. How will you get that? We use sine rule. Okay, sine theta will be what? Opposite, that's this length here, over hypotenuse. This is the hypotenuse. That's where we get the theta. How do you get this opposite here? This opposite here is the same thing as this 0.72 we have here. Okay, so let me just draw that shape here. This can be likened to having a shape like this. This will be 0.72. This is the resultant, whose magnitude we do not have. And what else do we have? This angle theta, the angle between the resultant and the river bank. Okay, let me just represent this river bank with color black. So this is the river bank. Okay, yeah. So sine theta is opposite over hypotenuse. This is the hypotenuse, which is the resultant. We already have the resultant as 0.9, right? Good. And how do you get the opposite? Do not forget that if we complete this rectangle, opposite sides are equal. Okay, so if this is 0.72 Newton, that simply means this opposite side is 0.72 Newton. Yeah, so we use sine rule for that, and we say sine theta is equal to the opposite. Sine theta is opposite, which is 0.72, divided by the hypotenuse. The hypotenuse is 0.9. 0.72 divided by 0.9, what would that give us? So 0.72 divided by 0.9 give us 0.8. So to get theta, we do theta is equals to sine inverse of 0.8. Theta equals to sine inverse of 0.8, and that will give us 53 degrees. 53 degrees. So that will be the value of our angle theta, 53 degrees. So we just put 53 degrees. That's the direction. Yeah, that will be the direction of the resultant, the relative to the river bank. So this theta here is 53 degrees. That's all. Okay, the next one. After 11 minutes, the swimmer reaches point Q. Calculate the distance between P and Q. What's the formula for distance? Distance is equal to velocity multiplied by time. Okay. After 1.5 minutes, rather. So what's the velocity? Velocity will be 0.9. What's time? Time is 1.5 minutes. You have to convert that to seconds by multiplying by 60. Okay. So you use your calculator to, yes, you have to multiply by 60 to convert from minutes to seconds. So let's do that. So if you multiply all of that, you get, what did I get? Let me check. When I multiply all of these, I got 81. So I put 81 meters here. 81 meters. That's the distance covered. Okay, easy. The next one. When the swimmer is crossing the river, his actions produce a constant forward force on his body. Explain why he moves at a constant speed. Okay, so how would he move at a constant speed? If his action is producing a forward force, why would he move at a constant speed? Because there is a force opposing his action, which is drag drag due to viscosity. That's friction in liquid. So this opposing force opposites the action force that it produces. So by the time you do the action forward force minus the drag, you get a resultant force of 0. Okay, when the resultant force is 0, that's when you move at a constant speed. Okay, if there's no resultant force, then there will be no acceleration. Okay, so that is what you write here as the answer to that. That's all. That brings us to the end of question 1. Okay, after this we go straight to question 2. Thank you for listening. You have a nice day. Goodbye.